Hello, everybody. Welcome to Discrete Mathematics for Computing. This is Professor Bob. So, we're going to have a short lecture today, and I'm going to kind of extrapolate a little bit on standard deviations and kind of put it in a little bit more context. Now, remember, a standard deviation is a few things. I mean, first of all, what it is it's a term that we use for descriptive mathematics when we look at a population. And it also is a measure of dispersion. Again, and that tells us how spread out a specific samples are around the mean. And it's also called, depending on your reading, a measure of central tendency. Now, a little bit more on that in an upcoming class. But what I'm going to do is I'm going to show you two different populations and how we can use the standard deviation to mathematically model things and draw conclusions from two different data sets. Now, as I like to point out, math to me isn't just, ones and zeros if you're doing binary math or if you're doing hexadecimal or ones and zeros or, when we were doing algebra or calc back in high school, we were always falling into that trap where we just would do an equation and we would get a number. And as long as you got the answer of x equals, y squared over 2, it's like, okay, well, that's right. Well, why is that right? What are we actually doing? We forget what we're doing it for. So what we're going to be doing here is I'm going to be doing the standard deviation in more of a context of something that you would do in real life. Now, what I'd like to point out is we use math every day. Math is something that you use professionally. Sometimes you look at some of the stuff and you're like, I'm never going to use this in my life, but you'd be surprised, especially if you work in the field of, being an analyst or a consultant, or if you're charged to look and find and describe different, like your customers, you're going to do this all the time. If you work in marketing, you use math constantly. If you become an MBA type where you're doing nothing but analysis, you're going to do math. If you're going to be working in the finance world, you're going to be doing math too. So it's not just, like a little fringe thing that you just do, from time to time. It's something that you use constantly. Anyway, I'm rambling a little bit. Let's go over the following scenario. Now, let's just say, we work for Bob Mobile, right? And we are a cellular phone carrier. And what we do is we have different customers. And for our purposes, we're going to break our customers down into guys and girls, right? We got guy customers and we got girl customers, right? Simple. Now, in reality, when we're doing this for Bob Mobile, we probably break our demographic down a little bit more. We'll probably have females between the ages of 8 and 24, females between 24 and 36, and all those other ones. It's the same thing with males. So when we're working with numbers with different populations like this or different data sets, we're probably going to be working with a lot of different ones. But here, let's just work with two. All right, so we're going to keep this problem simple. You can scale the problem up and work with, if you could do it with two data sets, you could do it with 70. So let's just do it with two. So we got boys and we got girls. So we work in marketing for Bob Mobile. And what we do is it's our responsibility as marketers to market and to sell things to our customer base. Makes sense, right? So while we're doing that, someone asked, they said, well, you know what? We need to find out some more about our customers. We need to find out about their spending habits. Because once we learn about our customer spending habits, we could market things to them, based on what they spend. If they're big spenders, we're going to market them things that are expensive. If they're not big spenders, we're going to market them 99-cent apps or 25-cent ringtones or something. But you guys get the picture. So basically what we're asked to do is we're asked to put together a mathematical model or a descriptive model. Remember, there's two types of math. There's descriptive math and there's predictive math, right? Descriptive math just describes things that we see, things that we could measure, things that we could sample, and we could use descriptive math such as, a standard deviation, which is a very simple formula for descriptive math, to do that. So where does that leave us? So what we do is we said, all right, let's go in the computer and let's get all the bills for the guys and all the bills for the girls. And this is what we came up with. So here we got seven, 1, 2, 3, 4, 1, hold on, 1, 2, 3, 4, 5, 6. So we have 8 samples. So we have 8 bills for guys and 8 bills for girls. Now remember, we're just using this as an example. Now in reality, this would scale up. The formula for a standard deviation is the same formula if we have 8 bills or if we have 80 bills or 800 bills, 8,000 bills or 8 million or 8 billion. This formula is still the same. But just so we can get our hands around this, we're just going to make this kind of small. So we get all the bills for our guys and we get all the bills for our girls. And we got them all right here. And again, in reality, this would be a set of numbers hundreds of thousands long because we have a lot of customers at Bob Mobile. So these are the bill. This is the dollar amount, what you see here, for extras that are on our customer cellular bills. So you have your plan, your $39 unlimited, your $59 unlimited. And also, if you look closely at your cell bill, I do from time to time, and I don't understand it. Sometimes I got to have someone look at it and they kind of explain it to me, and they kind of lose me. And I'm a math professor too. And someone can't explain to me how my cellular bill is because I'll look at it. I'm like, wait a second. If it's $49 for all data, all texting and unlimited, all this, what is this $7.25 for? And they're like, well, that is for your premium data. I'm like, wait a second, wait. I'm supposed to get unlimited data anyway. Yeah, but that's unlimited data up until a certain point. Then we throttle you, and then if you still want data at that speed, we sell you the premium data. I'm like, all right. So there really isn't an all-you-can-use data, right? They're like, no, it's all the data you can use. And then they explain it to me, and then I get all confused again. It's kind of like, I look at some of these cellular plans. It's like going to an all-you-can-eat restaurant, and there's 3 all-you-can-eat plans. Well, what do you mean 3 all-you-can-eat? It's all you can eat, right? Anyway, it's been a long day. So this is the extras that they buy. Like when you download something and you put it on your bill. Again, ringtones if they're still a thing, ringback tones if they're still a thing, and all the things that you buy from your phone that's put on your bill, right? So this is the monthly charges. So we look at our guys, we got $10, $12, $23, $23, blah, 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 all the way through. We look at our girls and we add all those up too. So this is what we need to do. What we need to do is we need to look at these numbers and we're going to model them and we're going to find out 2 things. Number 1, what is the average bill for the extras for guys, right? What is the average bill for the extras for girls? How much are they spending? And let's compare them. Also, what we're going to do is, in addition to looking at the average, which is the mean, but if you know me, the mean and an average technically is slightly different, but don't get me started. But for now, they're the same thing. And we're going to look at the mean or the average, and we're also going to look at the standard deviation. We're going to look at how spread out they are. So that's what we're going to do. So let's look at the boys. So this is what we got. We got the formula for standard deviation, right? We got standard deviation, right, which is lower sigma. Lower sigma equals a square root of sigma, right, on the numerator, sigma x I sub I, which means that we're going to have each sample in here minus me, which is, or mu, depending on how, well, it's actually me, but it's spelled differently, which is the population mean squared over n, which is the number of samples. Now, some of you have mentioned quite correctly that some of you will look at this formula. It's like, Bob, I've looked at this formula online and it's a little bit different. It's like n minus 1 rather than n. You're right, it is. There's actually slightly different formulas for the standard deviation that if you're looking at a population, the entire population, or just a sample of the population. So you keep that in mind. For our purposes for today, don't worry about it. We're just going to go over n. But in your reading, sometimes you'll see n minus 1. We'll talk about that later. Right now, it's over n. Done. Also, you might look at this data set here. It might look familiar to you. If it looks familiar to you, yeah, it's because we used it before. But you're not crazy. You have seen it before. This is what we call in the math world as repurposing your data set. That's what I did here. So we look at the boys. The boys have all their bills here. All right. There's 8 of them. In reality, 8 million of them. But we add them all up, right? So we got 10, 12, 23, 23, 16, 23, all the way through. So the first thing we do, right, if you remember about our standard deviation, is we got to get number 1, n, which is the number of samples, and then we got to get the population mean. Now, again, that's pretty simple. I mean, to get to mean, which is me, it would be 18. And I'll make it simple for you. All I did is I added all these up, right? Add them all up, divide them by the number of samples that we have or observations that we have. If you want to pause the video and do the math, go right ahead. I did it for you. We have a population mean of 18. Now let's get the standard deviation for the boys. So we can say here now, we got one of our answers. The boys, on average, spend an extra $18 a month on their cellular plan, buying extra stuffs, ringtones, blah, 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 games, whatever. All right, so anyway, so let's look at the standard deviation or how spread out they are. How spread out are all these observations around 18? So what we do is we do sigma x minus me squared. And I'm going quickly through this because you've already done the standard deviation. So a lot of this is kind of a summary of it or kind of like a review. So on the right, what I do is I subtract the each sample, or I subtract, the mean from each sample. I square it, and then I get my result, and then I sum my result, or sigma. Now again, this 192 is the result of the formula that we see on the numerator here. And again, this is the time where you're not taking notes. Good, you shouldn't be, but this is where you can stop this video and kind of like connect the dots. That's probably what you should do if you need to. Again, math is something that you do that. You don't necessarily take numbers down and take notes because it's kind of the big idea. But when you're doing an equation like this in a formula, this is when you kind of slow things down a little bit and say, all right, this goes here. This is what this is. And that's fine. That's exactly how this works. So anyway, so that's the numerator, and the denominator is 8, right? Because we got kind of going back and forth there. 8 is the number of samples. So we have the standard deviation is the square root of 192 over 8. That gives us a standard deviation of $4.89. So what do we say here? So we say here is that the boys, what they do is they have an average bill for their extras on their cell plan of $18 with a standard deviation of $4.89. That's how spread out they are. That's how tight they are. Like, for example, if all of our samples were 18, 18, 18, 18, 18, 18, 18, you know what our standard deviation would be? It'd be very small. It'd be 0, wouldn't it? So anyway, so we got a standard deviation of 489. Now, this is what I want you to do. If you want to, you can stop the video, and I want you to go and do the girls. And I'm not doing it for you. You guys got to do something. You guys got to work for a living. So what I want you to do is do that. So what you can do is go back. I'm just going to go back to the first slide. And we figured the boys out. Now you can figure out the girls. I want you to figure out the girls. I want you to give me their mean, about how much they're spending on their cell bill for, over their plan for extras. And I want you to give me their standard deviation. So In real time here, I'm just going to pause for like 5 or 6 seconds. In reality, this is when you can pause the video. And then when you're done, you can get back and we can compare your answer to what I came up with. So I'll give you some elevator music. Dun, 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 dun. Okay, you back? All right, so I didn't do the math for you, but this is what I came up with. So after I plug the girls' data set into this equation, I get the following. First, let's look at the boys. You've already seen this, but let's review. It's a new slide. All right, the boys have an average of $18, right? And a standard deviation of $4.90 if you round up. Okay, so what? So let's look at the girls. We look at the girls' bills. We get what for the mean? I did this on purpose, by the way. The mean is 18. So look at the average bill for our two populations here. Population 1 is the boys. Population 2 is the girls. It's the same. So that would be interesting in our marketing meeting. I'd say, you know what? I looked at all the bills and I took them from the computer. I put them in a spreadsheet where I wrote a computer program that does it, right? If write some Python code or some Java code to do this, that'd make you really employable, by the way. If you can write code to get these numbers and do this all in, you're making well over 6 figures. So, and it's not that hard to do. It really isn't. I can show you how to do it. Stick with me. So anyway, so I could be in the meeting and say, you know what? I looked at the average bills, and you know what? I found something unique. They spend the average same amount of money. Because I would think, well, if the girls spend more, maybe we could market them, more expensive things. And if the boys are cheap, we could sell them cheaper things, or vice versa. But if we look at this, we can draw a conclusion. Now, this is where I was telling you before. This is what math is all about. Math is about solving real world problems. It's about looking at what the math means. See, so when we're at this meeting, this marketing meeting for Bob's Mobile, no one really cares about how the formula works, just that it does work and we know what to do with it. You know what I'm saying? It's almost like this is the equivalent that I'd like to mention. As part of one of my hobbies is I restore old Jeeps. I haven't done that in a long time, but I still got one. I got two, actually. But in my life, I probably restored about maybe 15 old Jeeps. I just like doing it. It's therapeutic for me. I'm not really a mechanic, but it's something I take my time in and I enjoy doing. But anyway, by doing that, I use tools. I use wrenches. I use sockets. I use hammers if I'm slapping a starter to get something, working or whatever. But I use tools to do it, right? When I work on my Jeep. Now, there's not a class on using a wrench. Or if I want to learn how to use a wrench, there's not a class on it. If I want to learn how to use a hammer, there's not a class on it. It's just a tool. It's a tool to restore my Jeep. It's a tool that I use to fix something, to do something useful with. That's what math is. That's all math is it's a tool to get you somewhere to what you're doing. So just like tools are things I use while I'm fixing my Jeep, math is a tool that you use to do things like this, to do like market analysis. And let's go back to the Jeep analogy. If I was sitting with you at a bar and we're drinking something cold and we're talking Jeeps, and you're like, yeah, I got this 75 Wrangler and I did this. And I'm like, yeah, I got this 85 Comanche and I did this. We're talking about restoring Jeeps. We're not talking about screwdrivers or tools. We're not saying, so I was using a socket wrench the other day. How do you use your socket wrench? Because we don't really talk about tools. Tools just get us there. Tools just get us to get us to, fixing or help us with the task at hand. And this is what I think we forget about math. That's all math is. Math is a tool. So somewhere along the line, we forgot that math is used to do useful things, and we're stuck with in high school where as long as we get x equals 5 squared over 2, we're good. And our teacher says, geez, Bob, you got that right. You get an A for the class. And I walk out scratching my head saying, what the hell just happened? Okay, I got this number and I don't know what this number means. So this is a good example of how we use something simple like a mean and a standard deviation to model data to do something useful. In this case, for marketing for Bob Mobile. So let's continue with this, and I'm going to kind of wrap it up. So anyway, we look at their buying patterns, and they got the exact same average. But, some of you are looking at this and bursting from the seams. Look at the standard deviation. Remember, I mentioned the mean doesn't tell you everything, right? It doesn't. The average doesn't tell you anything. Although the average is a measurement. It is a measurement for descriptive mathematics, but it doesn't tell you a lot. Look at the standard deviation. Boys have a standard deviation of $4.90 around the mean, right? Remember, that's how spread out they are. Girls have a standard deviation of $7.55, rounding up from the mean. That's significant. So it's interesting to me that boys and girls have the same. On average, they spend the same amount, but girls on average are all over the place with their spending. We can say that even though their averages are alike, there's a lot of them that spend way less than 18, and some of them that spend way more than 18. So if I'm a marketing person, this is a significant find. I can say that boys don't really spend a lot more or less than the average, where girls do. So this would actually drive more analysis, where we would say, why is that? Why is it that girls spend on the average the same as boys, but their spending habits are widely different, where they can spend way less or way more? So that would be interesting, because I would be thinking about my product line and what I'm marketing. And I mean, some things, girls are going to buy over boys anyway. Like, if you're doing like sports books, it most likely would be boys. I know a lot of girls do sports books too. And if it's, an app for keeping up with the Kardashians, most likely it would be female, although I kind of watch that show too, but I probably wouldn't buy something. But other than that, for like gender neutral stuff, I would think that this would be significant, because I would say that we need to dig into this further, because what we're finding out is even though boys and girls spend on the average the same amount for extras on their cell phone bill, their buying habits still appear to be very different. So the standard deviation gives us another number to work with, doesn't it? See where I'm going with this? The standard deviation by itself is just a number, but now we're comparing it, and we're also comparing it to a mean. We're looking at the means of two populations and the standard deviations, and it's kind of revealing itself. It's almost like putting a puzzle together, where the more numbers you get, the more it tells us about our model and what our model is meant to try to figure out. And it's becoming more helpful for real world problems that we're solving. So this is all I had for you today. So thank you for watching. I bid you health, happiness, and safety. And I bid you all a very well rest of the day. Thank you.